We'll now transition to the next panel, which will be moderated by Prashant Shukla. So Prashant, if you want to come on camera, I'll introduce you. Prashant and I have worked together over many years. Me back to my U.S. Geological Survey days, Prashant back to his Government of Canada days in geomatics and mapping. And then since both of our retirements, we both actually spent a little time, me still there with WGIC. Prashant did some policy work for us. And Prashant, you are the one that, in addition to just the conversations that I had with Jeff leading up to this, of course, I've known Jeff for a long time. You probably are one of the few people that spoke to him right down the home stretch and talked about the energy and leadership that he's exerted globally for this. So I'm going to turn it over to you first to manage your own panel. And then I know after that panel, you'll be going into a more thorough discussion on Jeff's work and his legacy. So over to you, Prashant. Oh, yeah.
Barb and Prashant. Barb and Prashant, sorry to interrupt. Let's go ahead and quickly display those poll results. Maybe you can take a quick look at them, all right?
Great. Do I? Oh, okay, good. We do have them. So industry, almost half the audience is from industry. That's great from a WGIC perspective. And then it looks like we're fairly equally distributed between local, state, a little bit less for federal government, a little bit less for academia, and then 13% from some other group. So thank you very much, everyone. And geographically, do we have poll results in?
Just scroll down a little bit on your screen there on the poll.
Okay, thanks. Oh, was this okay? This is thematically that I'm looking at. Geez, nobody from agriculture, a little bit from energy, transportation, water, utilities, and other. So utilities and transportation. Biggest, maybe no surprise there because of the underground infrastructure piece. And then bulk, 83% from the United States. Good showing from Canada, a little bit South America, Europe, a little bit Africa. Thank you, both South America and Africa, and some good representation from Asia. Thanks, everyone, for doing that. Very much appreciate it. Okay, Prashant, over to you. I'll go back on mute and off camera.
Thank you so much, Barb, and thank you to the previous panelists for an exceptional discussion. I wanted to thank everybody for coming and attending today. And I'm coming to you from blustery Ottawa, which was Jeff Zeiss's home area, and from where he pushed a lot of knowledge and activity relating to underground infrastructure and the mapping of underground infrastructure. We have an industry solution panel. I'm very pleased to have Wes Kaiserschott, who's the national market leader from WGI Inc., Nicholas Smilovsky from Geospatial Solutions at Bad Elf, who are also one of our sponsors, Joseph Vladi from Lux Modus, the CEO and co-founder, Jason Spar, GIS analyst from GTI Energy, and Simeon Katiliev, who is the GNSS specialist and researcher at GTI Energy. One of the things that I'd like to do is I'd ask Wes to come on so that I can hand off to him, and then we can move into various discussions. And each of the panelists will be introducing subsequent panelists, so that we have a fairly seamless and fast and easy approach to things. So with that, thank you very much for the opportunity to introduce our esteemed panel, and over to you, Wes.
Thank you again, Prashant, for the introduction. Again, my name is Wes Kaiserschott with WGI Inc. We're a firm nationwide with our headquarters out of West Palm Beach, Florida. I'm in Austin, Texas. And as Prashant mentioned, national market lead for not only subsurface utility engineering, but also other geospatial services that we have at WGI, including aerial LiDAR and land surveying services that we can help in the collection of this data that can now go into the underground digital twins technologies that are coming. I saw some of the questions that maybe weren't fully answered yet, and I will be around for the networking session later of how the data is actually collected. Hopefully this presentation here will answer some of that, and how this data that becomes a 3D model underground and then gains some intelligence into a digital twin is actually collected geophysically. I wanted to start with a quick little history of Sioux and then a quick poll. Before I go to the slide after that, I want to put a quick poll up. SUE stands for Subsurface Utility Engineering, and it looks like the poll has begun, and this would be great. While I'm going over this history of SUE, let's go ahead and vote on this poll question, and it kind of helps me understand who's all watching this and the familiarization with subsurface utility engineering. But the history of it, some people think it's a very relatively new service in the civil engineering, transportation, land development world. However, in the 1980s is actually when two new technologies started, including air vacuum excavation and surface geophysics. And in 1981, a firm on the East Coast of the United States began what is now considered SUE. It didn't have that name until later on. In the 1990s, it actually then began to take off because Federal Highway Administration started promoting it. And Purdue University did a study in 1999 that showed a cost-benefit ratio of investing $1 in SUE during the design phase of roadways and other infrastructure projects could save almost $5 later in claims and in right-of-way utility delays on the project. So it really started catching wind in the 90s as certain DOTs began using it as test pilots. In 2000s, then it really started to expand around the country and around the world. I was very impressed to see what's happening in Singapore with our previous panel host. That was very impressive. So it really did begin to spread around the world, and it was recognized as an engineering practice when the American Society of Civil Engineers developed the 38 standard, which standardizes SUE across the nation, depending on what firm you are or what state you're in or where you are. Now today, we're actually in even more with this digital twin technology. I'm going to try to get a little better pointer here. In our digital twin technology discussions today, it's very exciting what's going on today in SUE. 3D modeling, turning into this when you're adding now intelligence to that 3D model. Conflict analysis, which is really part of coordination, but understanding what you have underground in that 3D model and then seeing how it conflicts with the proposed roadway or building improvements and to see where those clash analysis points are. And then very exciting for those of us in the SUE profession, which I think a number of people are on this call in the audience, is that about a month ago, the updated standard came out, and that was a 20-year wait. So it was the 3802 from 2002 when the standard was first established. And now we have 2022, a long 20-year wait. And it's published now on the ASCE library. 75-22 also came along with that update, which is really key in the utility as-built. Many state DOTs are wanting their utility information in a database now, where when the next project comes along, in, for instance, Colorado or Texas or Florida or Illinois, they'll know where their utilities are rather than having to scurry for records and maybe not get exactly what they need up front and have more delays. Before we go to the next slide, which will answer the poll question, do we have some results? We have some very smart people on this call. Very good, very good. But it's also really exciting too that not everyone on the call is a SUE expert, because how cool it is that we get to learn something new in the geophysical world and the geospatial world. So very good. The correct answer is 4. Pardon me as I try to advance my slides there. Okay, they are called the SU quality levels. If you think of quality levels as levels of certainty, in other words, how certain are you where that utility is located underground? Quality level D begins, and it's the least certain of the 4 levels because you're really gathering records. You're counting on records. You're counting on a site visit. You're counting on maybe an 811 damage prevention call where they'll go out and flag the utilities and mark, which is not SU, but it is damage prevention, and it does get you a understanding of who's there. Quality level D gets you that level of certainty. The next quality level is C. Now at this point, and we'll see some pictorials of what these levels look like here in a moment. But at this point, now you're surveying in some features. You found a fire hydrant. You found some manholes. You maybe found some fiber optic type communication lids in the middle of the street. And now you know where these lines are at that point. And then that segment of utility that is modeled or put into CAD is quality level C, because now you have some tie points. You have an anchor point with that survey. Quality level B begins a more precise location because now you're using geophysical methods. What are those? Traditionally, it's been electromagnetic, pipe and cable locating, ground penetrating radar, which we've talked a bit already with panel 1. Some of the newer technologies, thermal imaging, other kind of radio waves going in the ground, more improved ground penetrating radar that's high speed and 3-dimensional and can be mapped at roadway speeds rather than just a push cart method, which traditionally was used in the past. So many of that. You're actually now depicting it within a very small level of uncertainty. Usually you're within now a foot or maybe even within 6 inches. And most times right on that pipe or part of that pipe. So you've discovered it at quality level B. Quality level A is even better because now a vacuum excavation truck, which a number on this call might not know what that is, but fear not, we'll see a picture of that here soon. You're going out and you're seeing now the utility to its 3 dimensions in the X, Y, and Z, because you've actually non-destructively excavated down to the top of pipe. And you can daylight it, you can see it, you can fill out a sheet of attributes and actually develop a testral report, which you'll see an example of as well. So again, 4 quality levels, so good job to the 83% that got that right. And the others, this is a really cool to have you on the call to learn more about SU. Quality level D, again, the least certain. Yes, you can gather records, you can map it. This adds some value to a DOT, to a highway engineer. It adds some value. It adds a lot of value. If you're doing an environmental report, for instance, you at least know which utilities are there, whereabouts they are, where you can decide maybe the alignment of this interstate highway. Field visits, an 811 call. Again, quality level D is a records only based. Quality level C, we talked about. This is a picture of what some of these above ground features of the utility are sometimes called appurtenances. Whether it's a fiber optic communication marker, whether it's natural gas markers, whether it is a water valve cover or a water manhole lid that you see. Now that you survey in this point and you survey in this point, they are anchor points, and now you can display that utility between the points to the certainty of quality level C. Even better quality levels like we talked about with B and A, you're seeing an example here of why you don't rely just on an 811 call. What's an 811 call in the United States? All 50 states are have kind of a governmental state funding where if you just dial 811, not 911, but 811, you will get, and you tell where the project is, you will get a mapping of the utilities. Not a mapping, but you'll get a location with paint and flags in the ground. Many have done this when they maybe install a sprinkler system in their yard. What happened here was our company was tasked to find a water line near a railroad track south of Indianapolis, Indiana. And this blue line represented where the 811 ticket called the location of the water line. And you can see here where our technicians actually found the water line. Now that distance of a foot or two, it doesn't seem like very much, but it could be very detrimental if you're designing some kind of roadway feature that's going to get in the way, and that 2 feet can be very valuable right-of-way space. So SUE is defined also as a very professional standard of care, and that's why there's an ASCE standard of how you deal with the collection of the data of the utilities and where they're located. This is a vacuum excavation truck. So what you're seeing here is before we decided that that was a good place to dig a hole and cut through the pavement, we did quality level B to designate that water line. And that gave our crew the certainty to go ahead and excavate down to it. And that's where we found the water line. Again, this was an 811 ticket. It did show us that we were in the right neighborhood, if you will, but here we found it through the professional standard of care of subsurface utility engineering. Here's what a deliverable looks like. Now we're talking about 3D modeling and digital twins a lot today, but really in the beginning, and what a lot of clients still find valuable enough is a 2D quality level B deliverable. But we're finding that it's not enough, and a lot of DOTs are really going towards the 3D. But I just wanted to show you what a 2D deliverable is. And you can see a good layout. You can see where the roadways are. You can see where the utilities are. They're color coded as to whether they're a water line, whether a fiber optic, whether they're a natural gas, whether they're an electric, buried or overhead. You can get electronic depths. You can see this is an electronic depth of plus or minus 6.5 feet is where our instruments show that water main was buried. Again, you can't count on that until you actually excavate down, but there are instruments that show you approximate depths. So when you get to the quality level A, here's a little bit more of a zoom of what was going on there in Indianapolis. When you get down to it, you can see, saw cutting of the pavement occurs. Then you get down and you can actually, then we excavate down. And this is what the SUE profession does when tasked with quality level A. You're exposing that pipeline. Now you get to take the diameter of that pipeline. You get to see the material it's made of. You get to see the depth. Now you have a lot of attributes. Not only do you have the XYZ coordinates, but you have a lot of other attributes as well. The material type, the active status is maybe not exactly certain. However, you could hot tap into this if you expose it like that and see if that line is active or not. And these other kind of attributes. Now, when you do a test hole, then you get one of these reports, and the SUE standard talks about SUE reports, and this is one for one test hole where you get aerial images, you get some pictorial of what that utility configuration looked like. In this case, it was a multi-duct system, and then you get pictures of it, and you can see where the crews actually measured down, and then it was surveyed in later if the client needed that. So how are we collecting this data? This is kind of what we do at WGI. We're a full geospatial firm. We are collecting data not only on ground level with trucks and crews. We're collecting it in the air with fixed wing, high imagery, calibrated sensors. I know our host from Singapore showed Leica as one of the companies. There's Regal, there's Leica, there's others out there that are providing that fixed to the aircraft, providing very high density imagery, even picking up where you're marking the utilities. The LiDAR technology does. Here's a drone. You can certainly fix a camera to a drone as well. Here's somewhere you can put it out on the water and get some information as well. Here's some SUE being done, and then a picture of what you can find underground. And here's traditional land surveying techniques that are going on too. This is a lot of ways to actually capture that data that can then be modeled, that can be turned into a digital twin. And this is just a picture of what we can do, aerial imagery. This is not a picture above a railroad yard. This is actually millions and millions of points of LiDAR being beamed and then extracted into from cloud data, extracted into a model, and how that looks even like a photo, but that's just a lot of points extracted into a model. We saw some very impressive things there on some of our previous panels work, where the work was being modeled there. I believe that was also in Singapore. You can see how these LiDAR points also will collect even the top of rail from a plane thousands of feet up in the air. This happens to be a G2 sensor by a company called Teledyne, and this actually will fix to an aircraft and capture this information from the air. These are elevation points from low elevation in blue to high elevation in red. A lot of information being captured there. And you can see how more data can be captured using LiDAR technology. All this can then be used to model, and then the data fed in, as our panelist from New York City has described, into a very valuable digital twin. So, oh so close. This is a deliverable that WGI did recently for a client, where we took LiDAR above ground and did a building information model, a BIM, of the building and everything above ground. And the client then wanted also the utilities mapped underground in reference to it. So they got a full picture of above and below ground. So imagine adding intelligence to this natural gas line or this electric line. And by intelligence, that means what's the flow rate? What's the pressure in that water line? Well, that digital twin then, where the digital twin of information can then be used with the actual representation of what's out there for like a natural gas company or a public works company of a city or town. So a deliverable here of 3D SUE gets you oh so close to the next step of developing a digital twin. My last slide here, the possibilities are now, and credit here to an Esri site. All of us have heard of Esri, I'm sure, and this photo comes from them. So here's an idea of water lines mapped to 2D, and then you have some modeling above ground, and this is just the type of thing now where that digital twin can show you tank capacities, it can show you pressures, it can show you layouts here of where it is, within this part of a city, in the vicinity geospatially, where you have all this data due to the modeling of utilities. So that is my presentation. You can't do any of this stuff without being able to have good survey and good data collected very closely. It doesn't do any good. And so I turn this over now to Nick with Bad Elf.
Thanks, Wes. I really appreciate it. Let me go ahead and share my screen. All right. So in my short little presentation slot here, I am going to discuss anchoring the digital twin ... in reality. What I'd like to call XYZ marks the spot. Thank you, everybody that's joining us today and attending. We appreciate your time. Also, thanks to all of the presenters and sponsors and guests and hosts. This has been a great event so far. It's a hard act to follow. There's been some really great presentations, but I think you will quickly see how Bad Elf fits into this world of the digital twin and smart cities. And we'll, again, be talking specifically today about anchoring the twin. So we'll do a quick introduction to Bad Elf. So if you have not heard of Bad Elf, we'll tell you who we are. We'll quickly discuss our GNSS technology, specifically our Bad Elf Flex. And you can see the cowgirl on the right-hand side spinning the GPS devices. We'll discuss anchoring the twin, and I'll leave you with XYZ marks the spot. So who is Bad Elf? If you've not heard of us, Bad Elf is a line of GNSS receivers. We work with primarily GIS and survey professionals to collect high accuracy data. We are in what is called the BYOD, bring your own device space. And so we're a little bit of an alternative low cost GNSS solution to some of the bigger dogs that have been on the market for decades and decades. We are about 13 years old, and we interact with a plethora of different types of software packages, ranging from utilities and engineering to GIS to mapping to aviation to marine. We'll take a look there. We also like to dance with all of the devices out there, so Apple, Android, and Windows. All of our receivers have integrated LCD screens and intuitive user interfaces. This is something a little different than a lot of the other GNSS or global navigation satellite system or satellite system providers. We like to have a screen on there so our users can really see the metadata, what's happening underneath the hood as you're collecting, but also have the ability to use the buttons to collect right off the device. Originally, when we got formed about 13 years ago, we were primarily in the aviation industry. Fun fact, if you are talking to a private pilot or a commercial pilot, there's about a 30 to 40% chance that they have a bad ELF GPS in their cockpit. So we've been helping millions of people fly safely around the world for over a decade. We've also been in the marine industry. We work in the recreational sports industry. So if you're a golfer, a hunter, a fisherman, but most importantly for what we're talking about today is this GIS mapping, AEC, architectural engineering consulting, land surveying, engineering, SU, land development. This is all sort of wrapped in together. This is our most recent segment of business and sort of been evolving to get here. What you see on the screen here is one of our GNSS devices. We have several, but this is our flagship device. It is a fully survey grade, low cost alternative, quad constellation, multi-frequency. It has all the bells and whistles of a GPS device that is extremely ruggedized, easy to use, and a little different because you can even tell that the shape right away doesn't look probably like your traditional hamburger GPS due to the fact that we use a helical antenna. The key here is that the Bad Elf Flex will get you a centimeter or better accuracy all day, every day, for one of the lowest costs on the market. And this is really the crux of the presentation today, that we need accuracy. So if you were to look at a normal cul-de-sac in a neighborhood in the United States, you could estimate about 10 meters would be the circumference of the circle. And as you go in through those concentric rings, you get to higher and higher accuracy. And so some say GIS or mapping grade GPS devices 1 meter or worse, or let's say your cell phone, for an example, it is not going to be able to map the data accurately enough to anchor the digital twin effectively. This is where it's kind of this Goldilocks situation in which we want to have the porridge exactly correct. The better the accuracy, the better the model, right? And so we really want to start, if you're not doing it already in your organization, collecting high accuracy data. We've obviously seen a presentation from New York that was great, in Singapore. These are major metropolitan areas with a ton of infrastructure under the ground. If we don't start mapping these things with high accuracy and precision, we're going to have accidents. And so this is an example, Royal Oaks. This was in Michigan. It's a few years old at this point, but a gas line was hit and there was loss of life and millions of dollars worth of damage. We're not going back in time, right? So the underground is only going to get more complex, more complicated, more packed in there. And so we need to start really utilizing some of those new SU standards and mapping standards being rolled out to highly understand authoritatively where our underground infrastructure is. Here's another example. This is from about 5 months ago. This is a post hole digger that accidentally hits a gas line. Luckily, this person survived. But this is another great example that even in a rural area, like on a farm, if we don't know where the utilities are underneath, that's a huge safety issue. And that's only part of the pie, right? If you do a Venn diagram of all of this, we need to also understand that the digital twin, BIM, smart cities, that's also on planning and management. It's the 4D, 5D, 6D, money, time, and the management of systems, not just the safety. So there's so much involved with the digital twin. To understand why accuracy is important, right? So GPS or GNSS provides a location, an X, Y, and Z. We've seen that in some of these presentations. Without an accurate X, Y, and Z to start, everything else downstream of that initial point, or what surveyors, our geodesists will often call the point of beginning. It's the first point of the survey that anchors everything. There are two concepts called with accuracy. There is absolute accuracy and precision. These are both important things that your GPS or GNSS device needs to provide. Absolute accuracy is how good is your model to the real world, right? So if you have a location in your model How close is that location in the model to the real location on the Earth? Precision, though, is a little different, but also extremely important. It is the repeatability or the precision within a single data set. So instead of worrying about the real world, what I care about is, what if I'm measuring from one end of the pipe to the other end of the pipe within the data set? Is there drift? Is there margin of error? So both precision, repeatability, and absolute accuracy, how good we are into the Earth, is really important for the digital twin. So Bad Elf, we create, again, super affordable GPS that provides that initial XYZ, whether you're using Basin Rover or you're collecting utilities above ground or using drones. All of these situations require an original X, Y, and Z. Some new drones, for an example, you may be thinking, well, this isn't underground. Well, you still have to have an X, Y, Z established to go either above or below ground. You could be flying a drone, you set control with your GPS from Bad Elf, and the drone could be using radar, right? And so there's actual ground penetrating radar on drones now. So you can see here the GPS in different modes, drones and lasers and Basin Rover. We've got GPR devices attached to our Bad Elf Flex. So now you're, again, scanning underneath the Earth. But if you scan underneath the Earth and you don't know where that is in relation to other objects within your project area or to the real world, this is a problem, right? Ground penetrating radar, it will help you find these locations of items under the ground or assets under the ground. But if you don't have a good establishment above the ground, it's all hogwash, right? Like, you can have a great model, but if it doesn't fit appropriately, it's not truly intelligent. Here's a great example in Queen Creek, Arizona, a customer of ours that literally attached their Bad Elf Flex to an e-bike and a GoPro camera with Esri ArcGIS field maps. And as they ride around the city and collect water mains and other valves and other type of utility infrastructure, they are collecting it with extremely high accuracy of a centimeter or better, data. So you can be collecting remote sensing with drones and LiDAR and GPR, or you can be going to assets one by one. You could be opening up a trench and putting GPS down in the trench. You could be doing directional drilling and following the line of the drill with GPS. Or, as Wes mentioned earlier, if you've got 811 coming out to your site and they're spray painting where the utilities are, you could actually start mapping where those utilities are being placed by the locators. And in fact, we have our Bad Elf Flex that pairs just fine with some locators. So now that 811 is actually doing mapping and it's storing that mapping into a database. So XYZ marks the spot. Keep in mind, CRUD in is CRUD out. If you don't start with a good lat long and elevation, the rest of your model will not be good. I promise you. You've got to start with a good point of beginning, right? You don't want CRUD in. You want magic in, magic out. The digital twin begs you, please, right? Like, start using high accuracy, precision, keeping in mind that accuracy is addictive, but it's extremely important, especially when we're talking about utilities and confined spaces. You've got to have a established authoritative XYZ, and that's what I've got. So I am introducing our next speaker. Our next speaker is Joseph, and he's coming from us from a little bit of a different perspective. But if Joseph, you could go ahead and turn on your camera, I will stop my screen share. But Lux Modus will talk to you a little bit about the software side of the world. And Joseph, it's all you.
All right, thanks, Nick. A really interesting presentation. And thanks everyone for joining, and for the panelists today for presenting their solutions and being available. I'm just going to share my screen here. My name is Joseph Pallotti, and I'm the CEO and one of the co-founders of Lux Modus, and we are a hardware-enabled SaaS company providing rapid 3D mapping of infrastructure assets. We started in the pipeline industry here being in Alberta, and we've quickly expanded to the other large linear asset market verticals, particularly power lines and rail road. And an integral part, or a key part of any linear assets are subsurface utilities, and of course the above ground utilities. We're here today to talk about SUU. The background of LuxModus is that we found all of us founders came from the construction industry for utilities, particularly large transmission systems for power and for pipelines, but still utilities nonetheless. And we were always, like many people, sorry, I jumped ahead there, many people in the industry frustrated by the traditional data collection methods, which we're all talking about today. Bad Elf is a great example of bringing technology to the field to improve the methods, but traditional methods of collecting utility data and subsurface data is slow, it's expensive, it can be very hazardous at times, especially more on the pipeline side and in northern climates and so forth. And as we all know, not collecting subsurface utility data or collecting subsurface utility data often interferes with the schedule and operations and so forth. More on the side when we don't collect it and we have an incident or we find something that shouldn't be there or we didn't think was there. It's a major problem. That's why we're all on this call today. But one of the other major challenges is that collecting subsurface data or creating a digital twin and all the traditional survey that goes on out there requires specialized equipment, software, and certainly training. So LuxModus was created to mitigate all five of these major issues in the industry. So we've developed a technology suite of both hardware and software that basically make collecting surface data, 3D data of assets from LiDAR and imagery extremely easy, very inexpensive, and extremely fast. You're just looking at a video here of a large diameter pipeline project in Canada, which I'll give some more examples of in a second. All this is created just in minutes of driving down the right of way and collecting the data. Sorry if the video is getting a little choppy here. That's the nature of the internet. But our focus was to develop technology would make it easy for anybody to go out and create a digital twin of their assets. And as we know, the digital twin is the anchor point for all the other attribute data that is collected for the utility. So the system that the hardware and the software we created is extremely hands-off. Training literally is 15 minutes or less. It takes about 10 minutes to learn how to set up the equipment mechanically, and their equipment doesn't even have an on-off button. You just go out and start collecting data, and you drag and drop it to the cloud, and you get fully processed point clouds and registered imagery of your assets instantaneously. So there's no software to download, there's no software to learn. We're really trying to democratize the collection of 3D digital twin asset information. We bring in not just the hardware and the processing software, we also have visualization capabilities for our customers, so they don't have to buy necessarily your traditional GIS or CAD software, LiDAR software, just to look at LiDAR and do imagery or feature extraction and measurements and things like that, and do it right on their phone in our browser application. But pretty much most of our customers are similar, or analogous to people on this call. They have their own GIS and their own mapping capabilities, so they're just looking for that data to be delivered. That's the majority of our customers, and we provide all of our data in industry standard formats. Just quickly, as I mentioned, we started in pipeline, but we're basically in all the infrastructure market verticals, all of which clearly touch the utility aspect of digital twin. Now, I've selected some photos here. Not all of them have utilities in them. You can see in the rail example and in the built environment example, there's surface utilities, and obviously you can see that our technology is to collect subsurface data as well. But our technology is used for above ground data collection. So, part of subsurface mapping is mapping what's above ground, the power lines, the poles, the conduits running down the pole into the ground, the control boxes for lights, power boxes, intersections, the pedestals for telco, all that kind of information can easily be collected and somewhat automatically extracted from imagery and point clouds from our system. As I mentioned, we're in other market verticals as well, but our primary focus is on power lines, rail, and pipelines, and supporting subsurface utility. Our system collects ultra high resolution point clouds and extremely high resolution imagery. All the images you actually see, the one digger there and tank battery right there, are collected automatically from cameras on our devices that are that are also geo-referenced. So to that point, one of the values of our technology that we bring to the industry, while you're building an asset or it's a brownfield piece of work, say you're doing a dig and repair, our survey customer partners often use our technology just to capture the information of the dig and repair, what they found, but it's also used to create the actual digital twin of the asset during construction to support the overall as-built process. A key part of that is the ultra high resolution imagery that our system provides. Here's an example of the two images on the right of the screen. The upper image is of the LiDAR of one location, and the image below that is actually a camera from our camera system, collecting the high resolution imagery of that exact location, the LiDAR as well. You can see the resolution of our images. When our system is close enough to the target, we can actually automatically read barcodes and QR codes off material as well, and automatically geospatially index those for customers for attribution. So for survey partners out there, one of the biggest values they see in our technology is just the QC of attribution from construction in the field, that if they forget something or something isn't typed in correctly, or hey, they're missing some welds somewhere, they can always go back to the imagery and look things up. You can read the stenciling on pipe. You can see the kind of coating you have on conduit. You can see the type of joints that conduit is put together with. All that improve the overall attribution. We already have documented cases of saving our customers, several of our customers, millions of dollars just from attribution correction in as-built alone with our technology. Just another piece of eye candy here, that these are 3 images of the exact same spot. The one on the left is obviously from the camera, and the one on the right is the intensity and ambient IR LiDAR value. So we are a strategic partner with Ouster, which is one of the world's leading LiDAR manufacturers. And one of the benefits of Ouster, and the reason we went with them, one of the reasons we went with them, is being a pure digital LiDAR system, but also in addition to collecting the intensity value in return, their system also collects ambient IR value, which is the image on the top image on the right here. So you get both intensity and you get ambient IR from the Ouster sensor, which through digital signal processing can add a lot of value to automated feature extraction and object recognition technology. So just quickly on some outputs, most of our customers, as I mentioned, and partners have their own GIS departments and geospatial CAD capabilities, but often we get asked to provide that as well. All of our data is provided in industry standard format, so it can go into a GIS, such as the image on the left. The images can be mosaic, and you have images of that's a 6-inch natural gas pipeline. The image on the right, LiDAR, that's 24-inch gas pipeline as well, undergoing a creek actually in that image. And then the image on the right, and the bottom right, I guess, do I have a pointer? I don't know if I have a pointer or not, but is crossings from a major construction project in northern British Columbia. So another one of the benefits to our large operator partners, customers, is the fact that we help them with crossing management, which is obviously part and parcel to Soo, right? So that's the ultimate theme I want to leave with you here. And here's an example of a crossing that was discovered in northern BC, which didn't exist in any as-builts out there. The ability to collect, I think one of the things that's going to help with Soo going forward is automated updates of data via automated processing. So coming across a crossing like this, where clearly in a point cloud, technology can be used to automatically calculate the depth of cover, the clearance from the pipe going underneath it to the bottom of the pipe being crossed, the geospatial location and the azimuth of the pipe. That can all be automated. And to some degree, there's people out there working on automating that technology right now. So to both previous presenters in Wes in particular mentioned that subsurface utilities are not going away. We're only adding to them. One of the ways to through attrition, just update the data that's out there will be through automatic data collection and automatic updates during greenfield and brownfield construction projects. And that's one of the things that our technology brings to the table. So I think, that's the end of my presentation. I look forward to the panel discussion. I'll stop sharing. And if Jason, if you want to turn on your screen, our next presenter is Jason, who I've known for a number of years. And I'm looking forward to meeting his colleague here on this panel. Jason is with GTI, the Gas Technology Institute in the US.
Yes,
right.
and thank you, Joseph. Appreciate
Over
the
to you,
introduction. I'm also going to let Simeon share his screen. He's my coworker here at GTI Energy, and we'll just give a real brief intro on who we are and a couple things that might relate to this discussion today. So, Simeon.
Yeah, thank you, Jason. Hello, everybody. My name is Simeon Kevliev. I'm Senior GNSS Specialist over at GTI Energy. And we don't have a watch presentation. Everything so far was awesome. Thanks for having us today. And all the presentations that we've seen so far are great. Just a brief introduction about who the company is and what we do there. GTI Energy is a research independent non-for-profit organization. We were established in the natural gas industry about 80 years ago, and we went through rebranding just recently this year and moving more in transitioning into support of the low carbon and low cost energy systems for the future of our energy. We have headquarters in the Chicago area. This is where I'm and Jason we're located, but 5 other satellite offices across the country, and about 28 laboratories over there as well. So we do research in all aspects of the energy spectrum, anywhere from the downhole to down to the burner tip in the houses. Conversion and supply and delivery and utilization. So a huge portfolio of research. We work with a number of stakeholders in the industry, obviously federal and state governmental agencies, local utilities, both gas, electric, technology providers, equipment manufacturers, and infrastructure operators, and pretty much everyone who's playing in the industry. So again, the main vision for the future for a company is moving into that low carbon, low emission, low cost energy systems. I'm going to move to the next slide. So we obviously work in hundreds of different efforts simultaneously, but just to highlight a couple of things related to the underground industry, we have several projects going on that we do technology evaluation and development and partnering with technology providers for subsurface utility locating. What you see on the slide is one of those projects where we did locating, testing of locates that can provide mapping. They either have integrated high accuracy GNSS, or they have other mapping capabilities, or they use some external software for that. But either way, there's a lot of systems out there today that can do those kinds of mapping activities. So at the same time the locate is performed, instead of putting spray paint on the ground, you can actually put it on a GIS or CAT or whatever mapping system the company is using. So we did extensive testing on those. What you see in the middle of the slide is a baseline that we established last year. It's in our so-called pipe farm area in our campus in Chicago. We've laid down pipe, and we mapped it with high accuracy, scanned it, even flew with drones and everything we can to establish high accuracy location of the pipe. And then we buried it, and we performed testing of these technologies, not only EM located, but also GPRs and other technologies that are currently in development. And we also did testing around the country. There's a couple of pictures on sites from our utility customers in different parts of the United States. But at the end of the day, we achieve results, and we provide accuracy measurements of the final data that's being captured from these devices. I don't have that on the slide, but we also have an extensive GNSS testing program, and It's something that I'm actually involved with for about 4 years now. It's called GNSS Consortium. We evaluate GNSS technologies, and we provide non-biased opinion to our customers of how they perform, what's the accuracy, what's the performance, and the real world experience you can see with these devices. And that rolls back a little bit to what Nicholas was saying about precision and accuracy and understanding what is that 1 centimeter tell you, how realistically how is it achievable, and what devices can do it. And for the next slide, I'm going to turn it over to Jason to just highlight a couple more projects that we're working on.
Yeah, thanks, Simeon. So kind of playing off a little bit of what Simeon was showing with the high accuracy data collection from above ground with utility locators, EM and GPR. On the left side of our slide here, we actually have a project with the California Energy Commission. They have interest in seeing visualization of these assets underground in real time. So we actually created an application to collect points and lines in 2D and 3D. In real-time Bluetooth streams from locate devices, some paired with high accuracy devices separately, or some are actually have their own embedded antennas and what have you. So kind of a little image of some of the points and lines in 3D to the right of our data collection form. And then down below is sort of actually taking a little bit more of that look of what do we have underground? This is just some sewer data that came from local government and mapping that with the inverts. And then the yellow line is actually a gas line. But when we think about digital twin, a little bit can happen from above ground, and we have our plus or minuses we have to be careful of in the Z dimension as well. But we also have open trench data collection, other efforts that are grabbing all the assets, the barcodes and everything, and planting that into the ground prior to being backfilled. So that's what that's representing, actually. So you can kind of think about all these different facets of how you get your data, and then a little bit of that quality level for sure of if just because we can do it, and it's there and it's our GIS, we need to make sure we have some wrapping around that to ensure that we have some of these accuracy levels denoted on our data. So that was one project that we're kind of still working through with some pilots in California and collecting a couple miles of pipeline in real time. So a little part on the right-hand side actually is our research efforts to kind of look at that open trench scanning scenario. So this is actually working alongside LuxModus and utilizing their scanners on side of a truck, and we also put it on side of an electric push cart. Did some testing here on an open trench at our campus, plus a local utility sponsor in the state of Illinois. And those are just some of the products that we get from the LiDAR point clouds. But what we're trying to do on top of that is the great products that come out of Lux that go right into GIS. We have the pipe dimension in 2D, 3D, but we don't have for local distribution lines are all the components in between. So what we started testing with image extraction or feature extraction from imagery. So we kind of think about LiDAR allowing us to extract some of the pipe and create a center line. Then we have to think about all the other components in the ground, such as examples here where two pieces of pipe are fused together, like a weld in steel would be a butt fusion in plastic. And so we were building a library and testing it out so we can kind of marry the scan data and give it some more information to kind of start to fill out that digital twin. No barcodes yet, but the idea would be to build a library of these components so the images can pick them up and actually extract them into GIS features, and then smash them in there with all the other great extractions that come from products like LuxModus. And we start to build a little more of this picture of what's going on underground with the one pass system, a lot more automation, less time around the trench. Less fat finger data entry issues. But then again, this has got a long way to go, but it's a nice segue into some of the work we're doing into representing the underground digital twin. So those are the slides we have. And I think that at this point, we are going to turn it back to Prashant. I think we're going into the open panel discussion.
Great. Well, thank you very much to all of the panelists for absolutely excellent presentations. I always come away from these events just blown away by the work that everybody is doing. I think there was a point at which, when we were organizing the panel session, that I was asked to provide some comments around what I thought the role of industry was going to be in this area. And I think, as you can see by the variety of different types of presentations and the different types of products and services that are being delivered, as well as the policy intent and the policy rationale behind them, I think it's that old answer about, what are the impacts from the French Revolution? And the answer is generally it's too soon to tell. So I really do think it's too soon to tell. I think there are opportunities for a lot of work to be done in the area. And it seems like there is a significant opportunity for any private sector company to help define the future. With that in mind, I'd like to open this up for some discussions. We are going to go forward and take a little more time than we have, as the presentations haven't gone on for a while. So we do have a bit of time to cheat a little bit. And I invite the panelists back on, and I see them coming back on. And with that, I noticed that our Q&As have been quite active, and I did want to try to get some of them answered. One from Connie Barrett, who asks, and I believe this would be for Bad Elf, and that is, how are the differences in datums being addressed when data is being collected in large geographic areas?
Yeah, that's a great question. I think a couple of these questions actually are sort of merged all together. So let me go ahead and start by saying what I was discussing is called a GNSS. So it's a global navigation satellite system. It's not just GPS. GPS is a single constellation of satellite where we are accessing a quad constellation of satellites. And actually, to get a higher accuracy, we're actually connecting into an RTK, so a real-time kinematic network, or we're setting up a basin rover UHF connection. So when you tap into most RTK networks in the United States, immediately the datum that's going to be used most normally is NAT83 Realization 2011 GCS, and that's what they're being broadcast in. Bad Elf then takes that native information via the NEMA stream, and we can parse that out to any software you'd like, whether it's a heavy survey software or a GIS software, and then you can do any transformations you would like on that. As part of that metadata that we send to those apps, or our own app, includes timestamps. So there's a very real question here that, as most of you probably know, that this year we were supposed to have in the United States a new datum. So NAT83, the North American datum, being almost 40 years old now, was supposed to be replaced by the North American Terrestrial Reference Frame, so NatRef. Obviously, COVID threw a wrench in things, and so it slowed this down. NatRef is a dynamic datum that accounts for tectonic shift. So when you want to talk about that, we are actually moving around. So we now get a timestamp with that, and we're accounting for the fact that we are moving on this rock, kind of dynamically. And so I just want to everyone to know that we at Bad Elf are 100% ready for that transition when that comes out. We're just waiting on the government, and that sort of ends it with what datums are we using? Well, if you are using a Bad Elf device without an RTK, you're going to be using WGS 1984, which is technically ITR F08, very, very close. If you're connecting into an RTK, you're NAT83 2011. Then most people, depending on where they are, will then project that to a local coordinate system like a state plane, where you're going one step further. And then it's really custom. If you've got a transmission line that's 1,000 miles long, we sit down a lot of times with our customers and we plot it out with them. Let's talk about what would be the best way to have a web map, to have local maps, right? So you're having that reduction in tearing and shearing and all of those issues. So a lot of it is consultation with our customer. We just don't hand the hardware over. We say, let's put together a plan that's going to work the best for your project. That's a long-winded answer, but sort of wraps a lot of those questions together. Hopefully that helps.
That's great, Nick. And I think the one other thing that I would just add on to that is that NAT also governs Canada and Mexico as well. So there are continental interests in that question, as well as in the changeover that is coming with NatRep. We have one other question, or I think this is more of a comment around horizontal accuracy. And one of our participants in the audience has said that, has urged us not to say that GPS is 1 centimeter or less in accuracy, and that post-process static GPS is capable of 1 centimeter at 1 sigma with properly designed network. Does anybody want to comment on that from a technical perspective in terms of your applications and how you've addressed that issue?
I can take that question. Well, just to piggyback on what Nicholas just mentioned, with the new reference frames that are being designed, it's going to be a big challenge for the industry to utilize that. But I think we need to all work together and get that move to that dynamic frame, because my background is geodesy and geophysics, and I'm getting my blood flow gets a little pressurized when I start talking about this topic. But this 1 centimeter thing is just unthinkable in the global scale if we don't take into account all of these things that are dynamically changing on a daily basis. And not talking about datum shifts, and tectonic activities, but there's geopotential changes there too that changes the elevation, which is the core of our GeoID model. And when we want to go to that global precision of that centimeter grade, everything is very very important. Every single component, the height of your pole, the tilting of your pole, the face center of the offset of your face center of the antenna, and the quality of your depth reading. Let's say if you're doing a locate, the quality of your depth reading, and all of that, and is very, very important to think about all this at all times. From the surveying perspective, surveyors, including myself, we love to have like one coordinate, one monument that never changes, and we take that coordinate and we use it as a reference all the time. But in reality, as Nick mentioned, that's just not the truth. Everything is shifting and changing, and everyone needs to be aware of that and taking that into account.
You're on mute, Prashant.
I just want Joseph to jump in as well.
Yeah. Thanks, Prashant. Really good comment. But what I'm just going to put a little bit of a bend out there, and I don't want to cause a controversy, which is actually in itself a leading statement. But everyone on this call, and I think most people tuning in, are practitioners, right? And we're engineers, we're geographers, and so forth, and we love the 1 centimeter discussion. But I just would put to people to keep in mind, and this is maybe an industry perspective or just me getting old, but to be pragmatic as well and practical, because 1 centimeter accuracy is great. Keep in mind a lot of the materials we put in the ground, that when they get cold, over distance, they contract by several centimeters. The ground shifts, people move, the earth subsides, you have a flood, it gets wet. So I agree that we should always strive for the best precision we have, but we're talking to ourselves. The end customers, the person, as mentioned in the earlier example, looking to put in the sprinkler system in their yard, doesn't care about the actual precision of how accurate that 1 centimeter is in the X, Y, and Z, but they're interested in the relative accuracy. That, no matter where the X, Y, and Z actually is, as long as relativistically, where I want to put my sprinkler tube or conduit is this far away from the fence post I have to put in the ground. That's all that matters. It doesn't actually matter what the X, Y, and Z is. I know that's just one example, but as we're trying to provide solution for the public and the people that could, we have to keep in mind too that there's, I'm not trying to say we should shoot for less, we should shoot for the best, but let's not cut off our nose in spite of our face. Okay, like the most important thing is relative. Now I know there's legal components, where's the curve and all this other stuff, but pretty much everything we're talking about here, literally talking about subsurface, buried. Days to weeks after it's buried, it's moved. Okay, it's moving centimeters here, it's expanding, contracting. A pipeline, it's hilarious how when we do natural gas and we survey in where the pipeline is, As soon as it's under pressure, it's moved and it's expanded. So 1 centimeter is not really, we don't want to spend too much time or money or make things uneconomical trying to go for that 1 centimeter. I think our biggest challenge in Sioux is collecting data, maintaining, keeping it current, but also putting the data in the hands of the people who actually need it out in the field and are building their fence, like that guy who hit the fence post or was putting the fence post in the ground in that great video. Luckily, he survived, but he hit a gas line. Relativistic, for the end user is probably the bigger issue, and the data has to be current and accurate, but it doesn't have to be 1 centimeter all the time. I just put that out there. We are not the consumers of this data. We're the practitioners of the data. The public is the consumer of the data. We have to look at it.
That's fantastic. It reminds me of some of the work that that was done in previous decades around things like spatial data infrastructure with respect to the collection of information and data, and how it should really be closest to source and based on user needs, on specific user needs. So that's a really welcome intervention, Joe. One of the things that this discussion has really raised for me is the fact that all of you are doing some really fantastic work in terms of visualization and representation of the digital twin. To me, it seems that it is more than a buzzword, but in terms of what the industry and what your clients are saying, is this something that you're using in your vocabulary as you're going out and engaging with clients, or is this really very much more business as usual? And at this point, I'd love for our poll to jump out and see what the audience thinks about this while we listen to some perspectives. And given we've had Joe and Nick jump in a little bit, I'd love to invite Wes and Jamie to comment first.
Prashant, do you want to comment after the poll data comes in, or
let's have people fill out the polls and
yeah,
keep talking as we go along. Sorry, not Jamie, Jason. Yeah,
sure. Did you want me to share, Prashant?
Sure.
From a Sioux and geospatial provider right now, we're not getting multiple requests a day, let's say right now, to produce a digital twin. What we are getting a lot of increased requests for in our scope of services is to provide 3D modeling of the underground utility map. 2D just doesn't cut it anymore. The client wants it. So the methods are out there, the new standard is out there to move that way. So we're not, the digital twin buzzword, it is something that's slowly coming into Sioux. It's not necessarily a scope right now, but the new standard leans towards it and absolutely allows for it in the capture of the data that is subsurface utility engineering. And I think the requests are going to come in more because these 3D models just sitting out there by themselves don't do a lot of good unless they're not smart models and have data to them. You can click on that building and you can get information from it. We're already there with GIS. So why not have a 3D model that also has that? So that's my thought from the Sioux and geospatial provider.
Great. Jason?
Yeah, buzzword. Yeah, I think it's also been around for a long time. And people can consider maybe different tiers of what they want to believe is a digital twin. It's a simple stage. Yeah, like Wes said, getting things into a GIS system. Now we have 2D, we have availability to do 3D, we do it in real time, we can make kind of a representation, we can scan barcodes, we could tell you exactly where those fusions are when you need to dig them up for regulation's sake. All that metadata that goes along with it. But then you start thinking about people trying to put the 3D visualization on steroids and saying, well, let's get the dimensions of what that 3D feature actually looks like. Let's add an IoT sensor to it. Let's build this model, as you saw, I think, Wes, you might have had it in your water model through Esri. That's sort of what I would say the future can be, but I think it's starting from a little bit of these representations and building up. Everybody's going to have a little bit different flavor of what they think they want to digitally record in different dimensions, and then slowly build to create this infrastructure. I just think it's going to take a little bit of time, and at least with our sponsors, some people are not ready for that. They're still trying to figure out their own solutions. Even in a 2D world, they don't always even love the 3D environment because they can't keep it up to snuff over time. So they don't want to collect that third dimension. People don't want to, with locators, even mark the ground for sake of being accountable. But will that change? And I think in the United States versus other places, we do need to start sharing that data too. And we need to hold it up to some standard, which, hopefully Sue can help us do. And we can start to get towards these schemas that are somewhat similar across the many different platforms of data collection, kind of like you have with NEMA and GNSS and things like that. And we start to build upon how these efforts of the people on the panel earlier are all going to come together to regulate this. And so you don't just build it and they come and you can do it. You have to have some accountability behind it and what those levels actually mean, so you can pre-plan and do construction properly.
Fantastic. Thank you so much for that. One of the things that I'd also like to bring in is the concept of a digital twin. And when you have virtualized environments, is there going to be a difference? And Earl Burkholder talks about the elephant in the room. And the fact is that there's a difference between true 3D and pseudo 3D. And whether that is something that the end user is going to be concerned with, and whether this issue of accuracy gets thrown into the mix in terms of the true 3D and pseudo 3D representations. And how about I just throw this out there to Joe and Simeon.
We seem to have lost Joseph. He may have dropped off suddenly.
Uh-oh.
Oh, you're here?
Well, Nick, do you want to take a stab at it?
Did you say me? So I haven't heard the exact the pseudo 3D quote unquote that's been mentioned. What I do understand is that we talk about the 3D, right? My iPhone, well, you can't see it because of the screen thing, but my iPhone has a camera and a LiDAR sensor, and I can go walk around and I can map out the 3D, right? The reality becomes, or maybe I shouldn't say reality because that becomes a bad joke here, but that device is not highly that accurate in a lot of circumstances. It's not going to have all this technology behind it. And so the three-dimensional modeling that you're producing because of that is going to be very off. It's not necessarily going to be true reality. So I definitely think as these devices get more accurate, when I started about 15 years ago, a LiDAR point cloud was really thick, right? Always. And you just got this massive amount of points that we've had to work through. And you realize at one level, like having a gajillion sensors and collecting 5 million points is actually overkill. And it's creating more fuzz and noise than you need. And you can run a 32, laser sensor instead and run a Calman, we've gotten better at it. So I think we have to just be very cognizant of what we're doing. And I'd wrap it in sort of to the last conversation about accuracy, right, and precision. This is, in my humble opinion, where we need professionals in the industry, primarily registered land surveyors, registered engineers, people that are going to stamp an authority, like basically say that not just the manufactured specs, not just what the client's telling me, not what my thumb is doing in the air, but I've tested it. I've put it through this process. I am confident that it's getting this accuracy under a tree next to a building. I'm confident that my model a mile down the road doesn't have a 4-inch drift. I'm confident that my model where the wall is actually where the wall is. It's not 3 inches recessed because of a thick point cloud. So I really recommend that people vet what they're doing and that they hire professionals that know how to analyze what they're doing so that you can truly qualify the technology that you're using, the models that you're making. So I don't know that necessarily answers exactly, but the world is so dynamic. I mean, Simeon mentioned gravity. Gravity changes, right? Like, how do we account for that? So hopefully that maybe helps a little.
It does help. Yeah, it does. We are nearing the 5-minute zone. There is a couple of other issues that I did want to raise. There was a question that Brad Cleaving has, and Nick, I'll get you to answer this very concisely, and then I'll bring Simeon back to make a comment. How do you handle dense canopy in multipath?
Very carefully. All GPS is going to be suspect to multipath. So if somebody's telling you that their GPS is better and it doesn't get affected or impacted, they're lying to you. And quite frankly, what I'd tell you, if you're in a really bad situation, put your Bad Elf device away and pull out a total station, right? Like the right tool sometimes needs to be decided. And if you're in downtown New York, that Bad Elf device may not do it for you. So the helical antenna for us helps with canopy, but we're going to be just as much impacted. And that's where an intelligent crew is going to make decisions and use the right tool in that circumstance. And, GPS, GNSS isn't always the right tool.
Great. And I would also ask everybody to take 30 seconds to finalize your digital twin, because in 30 seconds, I'm going to ask that Anne is going to close down and close down the poll and then share the results of the poll. And with that, I just want to say how pleased I have been to have shared the stage with all of you on the panel today. The presentations have been absolutely mind-blowing. I've really, really enjoyed them. As the former head of a national mapping agency in Canada, you can figure out how these kinds of presentations get me quite excited about the future and about the opportunity. And I guess it really does go back to that original comment about, what's the role of industry? Well, it really is too early to tell. And I think, it's really, the future is really unwritten. And with that, can we share the poll results and then go from there? Wow, look at that. Not sure, but I think it's something we want to be involved with. 31%. No, it is something we consider. It is something we consider on a daily basis. Wow, 40%. I find that really surprising. Really surprising. Yes, it's just a buzzword. Only 16%, and not sure 4%. I guess that shows my own biases. And does your firm or organization consider the digital twin on a normal operational basis? 51% said yes. Wow, really fascinating, really fascinating. So with that, I would also urge all of you to join the networking session. I would also urge everybody on the call here today to have a look at the WGIC report on digital twins. It's an absolutely superb piece of work. And with that, I will turn it back to our host and leader,